Hello, welcome to vsdevelopers.io. From this week, we are going to discuss object-oriented design principles. The topic is easy to understand and very difficult to comprehend and implement. So you would typically understand the definitions of what is abstraction, what is encapsulation, inheritance, and polymorphism easily. When it comes to understanding the existing code base or existing design of an application, you would need a thorough understanding of these object-oriented design principles. It is not necessary that you would always write a brand new code. You would most of the times work on the existing code that is most likely designed and developed based on object oriented design principles. So therefore it is very important for any programmer, for any QA engineer to understand these object oriented design principles so that you can develop and test the applications thoroughly. So these definitions now we will understand with various illustrations, code, and interview questions. It is not easy to cover all these topics in one video. Therefore, I divide this into each video. Let us begin with abstraction. Now, abstraction alone may not be sufficient to understand the concept. Therefore, we discuss what is binding and scope along with abstraction. Therefore, you have a thorough understanding of abstract data types. What is abstraction? When do you write it? When do you go for abstraction? How do you figure out that there is an abstraction in the existing code? You can easily say this is a dog. It has certain characteristics, it has certain features, and it makes certain noise. Well, when you visit a dog, do you call the dog as a dog? No, it has a name to it, isn't it? So let us call this dog name as Yali. So whenever you want to call the dog or play with it or give him a bath, what you do is you call Yali, come over here, so that the dog recognizes himself and comes to you. So what is name being used here? Name is used as an abstraction to set of characteristics, features, behavior. Same is applicable to human beings as well. A female has a certain characteristics and a behavior. Male has certain characteristics and behavior. Therefore, they do have names too. We are all referred by our names. And under the name, you have so much of complexity, isn't it? Now, let us simplify that complexity little more. By looking at this, you can easily say that this is an abstract painting. What is an abstract painting? It is the emotion and feeling of an artist. We all express our emotions and feelings in certain ways. So as this artist, and this is a common term, therefore I have chosen this to represent what is abstraction. Likewise, an ATM machine is an abstraction of so much of complexity. There are so many network calls behind these ATM machine that happen. They recognize your card and they check your balance, they verify your PIN, and then they let you allow to withdraw amount from the ATM machine. But you are not worried about it. What you need is money from your bank account instantly. Therefore, the ATM machine abstracts so many details, different behaviors of the machine inside. This is the example that we go and deep dive. So as your class. So here stack is a class name. This class has certain characteristics. What it does, as you know, stack allows you to push the data into it and pop the data out. So you push first, then you pop. Before you pop, you can check if it is empty or not. And you would need some data members to know whether the stack is full or not. This is the understanding of abstraction. Now let us get into more programming world. Every machine has its own architecture, and every compiler has its own definition of their data types. That is, how many bytes does the particular data type is being allocated, and what is the range that it can be stored. So when you know the number of bytes, you can easily know the range of the numbers that can be stored into that data type. So here on the first column we have the bytes, second column the ranges. Now do you refer to these, okay, I want 1 byte and I want to store this range every time that you want to use a byte? No. So the compiler abstracts all that and gives you a data type called byte. So as 2 bytes integer, this is a short integer. So whenever you want to make use of 2 bytes and store your integer, you declare a short integer, which is a keyword given by your compiler. Likewise, the rest of the data. So complex data that has a certain behavior, that has certain limits, are represented using abstract data types, which are in short known as ADTs. This is a simpler representation to understand all the abstract data types from uh, compilers. Like typically these are C data types and are known as primitive data types. Right? So here what you see is a set of integers along with their qualifiers, and then you have the float and double to store the real numbers, and you have the characters, and there is also representation of void data type. So these are the 4 primitive data types, are also known as your abstract data types. Little more about them. Name is a mnemonic character string used to represent something else. Now we are slowly diving into the programming world. Int variable. Variable is a mnemonic that we are using to represent something else, isn't it? So when you say int variable, now the variable represents that it is an integer that requires 4 bytes and that can store the range from -x to +y. The next, all your arithmetic operators are abstract types. All the operators, they go into your processor and does certain calculations. Therefore, you can consider all the arithmetic operators are abstract types. So as your high level languages, Java, Python, they hide so much of complexity internally, and they bring you an English like language so that programmers can easily code. Function method is an abstract data type, and pointers are abstract type, structure or class. Even your print method, takes certain arguments. Therefore you can say print hello, or you can say printf percentile c and your variable name. You see that it has so much of complexity under the hood, and yet it gives you a high level interaction with its behavior, and so that you can call it whenever you need by ignoring all the complexity that is performed by a particular function. Here is an example. So you give an input to a function, and then you give you get the output from the function. Now let's read this with example of a code. So you have a main method. So this main method defines you an application. So whenever you want to run this functionality, you go to the command line or you go to the application and run it. So when you run this application, what it does, it finds an average of these 3 numbers. So it has a certain functionality to it, right? Finding average of 3 numbers, and these members are your member variables, right, which are used to find the average. So this functionality requires these data members, and in order to you to see what is the average, we are printing it. So the entire job of this main method or this application is to find an average. Now you see it has a functionality defined for it, and yet you simply call application and you get the output. You see where I'm coming from. The entire complexity is hidden, its behavior is exhibited to you whenever you call it. So it is an abstract type. Now let's get into the class. So this is a typical class name, right? And then you declare data and functions inside it. Now you have understood what is the abstract data, and then how do you declare it. This is one declaration with C++ class example. This is an empty class, and this class is not an empty one, right? So you have this class has a name, like the dog had a name, and then it has certain characteristics and behavior. So this class has a functionality or behavior of calculating area and calculating volume, and these requires these data members. So this is a class and abstract data type. So in C++ word, you refer to abstract class is something totally different from what is abstract data type. So far you have understood what is abstract data type. Now what is an abstract class? Abstract class is a abstract data type in C++ world. Abstract class is different from abstract data type. So far you have understood what is an abstract data type. Now in C++ world, abstract class is an also abstract data type which has a function that is assigned to 0 and that is prefixed with a virtual keyword. This is equivalent to your Java interface. For now, you just get that. As we go into polymorphism, inheritance, we will write more code around virtual method, virtual keyword and abstract classes. Well, so that is about abstraction. And now there are a few questions before we dive into binding and scope. What is the size of an empty class in C++? The answer is going to be 1. What is important here is why it is 1. Okay, so the next question, what is the size of an abstract class? Just now you have seen abstract class with virtual keyword and assigned to 0. What is the size of it? Next one, so this is not an empty class, not a abstract class. It is a class that you typically use in your programs, which has a name to it and it has two methods. What am I doing inside the main function is I'm declaring an object of this class, finding the size, and I'm declaring a pointer to this class and allocating memory dynamically with the help of new operator. Now what would be the size of this pointer to an object? And the very first one, I'm directly printing the size of the class itself. I haven't instantiated the class, it is the class name itself. So what is the size of the class, what is the size of an object, and what is the size of a pointer to an object? These questions are going to reveal some of the very deeper details about C++ design and object orientation as well. Do you consider arrays, lists, maps, trees, and priority queues abstract data types? Yes or no? Next question, when does the binding happen to the abstract data type? Does it happen at the compile time, linking time, load time, or runtime? Well, now what is binding? There was an interview question in the prior slide about binding. Now, in order to understand binding, it is important. Now you knew that every thing is given a name which has certain characteristics, behavior, which does operations, and it has a name. Now, when do you give that name? Right? That is, when do you bind a thing to a name? So for humans, it's a naming ceremony. For dog, whenever you own it or adopt it, you name the dog. So that is binding. You bind a name to a thing. And how long does the binding live? As long as the thing or the person or the dog that you are naming is alive. You get that? And who all are aware of this binding? For a boy, obviously parents are aware. And for a dog, the dog owners are aware of that name. And few other people who are close to that family, or who likes the dog, who hates the dog as well, are aware of that binding of a name to the dog. So here, binding is an activity that you assign a name to a thing, and it lives as long as that particular thing is alive, and people who are aware can call or can use that name to call a particular thing or a person or an animal. Now let's slowly move from the illustrations to examples. So what do? So here, the shape class that we used in the previous slide is the name that you have given to it. And when are you binding it, right? So when you declare an object of this shape class, you are binding at the compile time. So when you compile this program, this name is binded to this class. And here p1 of 0, so there are two objects that we declared, which binding happens at the compile time, but when you are allocating memory to it dynamically, this binding happens at the runtime. So as this new triangle of p1 of 1 happens at the runtime. Now interestingly, when you call a function that is inside the class, this binding happens at the link time. So we have seen, right? So function is an abstract data type, object is an abstract, the class is an abstract data type. And so when does the binding happen? This is an example. So there is a method to this madness, when the binding happens and why it happens, which we will be seeing in coming slides. What is a scope? So what is a scope? With this telescope, you can see that when you use the telescope and look for a particular thing, it is only visible to you if a person standing beside you cannot see what you see. So which means that you have the scope of a particular item only to yourself. Nobody else can see it. The same is applicable to your data variables or the classes or your abstract data types. So how long the data can be lived, who can access your data, depends on the scope of the object. Now the scopes are like global, namespace, local, function, class, right? So a variable can be declared in a global space so that entire your program can access it. Or a variable or a class that is an abstract data type can be declared inside a namespace so that it is pertinent to only the namespace. And local, you can declare a block which you want to make it local, and all the abstract data types that you will declare inside the local block are going to be to that local block only, so as function and class. Let us drive through an example. Here what you're doing, this is a program, and line number 3, you have declared a variable called int global var assigned to 55. So since this is declared above all the blocks, this is going to be a global variable. And then the radius at line number 12 declared inside a class, therefore the scope is local to the class. Now inside the main method, you have declared object of shape. The scope of this is going to be throughout this main function. Now here you have declared another block. So inside this block, we have a variable scope var, whose scope is limited to the fur block only. Hope you are getting the picture of it. What is scope? Where do you declare and how long it is going to be alive? Now, to quickly revamp, you have given a name to an integer in line number 3, whose life is going to be throughout the program and who is accessible to complete program. The next, the radius at line number 12, the binding happened when this class gets initialized, right? And then you can access this radius variable only by the objects of the circle class. So as p1 is accessible only inside the main, and its binding, you see this happens at the runtime. So this is very important. And few interview questions again. Why should you have scope to the data? Right? So now you have understood what is local scope, global scope, namespace scope, class scope. Why should you have scope to the data? You might already know the answer, right, from the explanation that has been shared so far. How is global and static different? You might have heard static variable, right, a global variable. How are these two different? And namespace scope, when do you prefer to use it? When do you use the scope resolution operator? How do you differentiate between lifetime and scope of variable? The fifth one is a very frequently asked interview question. We have understood the scope now. Now, how do you understand the lifetime of an object? So here, this data type called human being has a lifetime, and we all know that. Now, likewise, a data lifetime is defined by its storage management. Where are you storing that particular variable? That defines the lifetime. See, the scope is something that you have understood, who all are aware of it, who all can access it. Now the lifetime is defined by the memory management of that particular variable. Creation and destruction of objects defines the lifetime. Likewise, your creation and destruction of bindings is also going to define the lifetime. Now, how is this different? Creation and destruction of objects and creation and destruction of bindings. That will be well understood with the help of dynamic memory allocation and pointers. Likewise, deactivation and reactivation of bindings that may be temporarily unusable. References to variables, subroutines, types, and so on, all of which use bindings. You will understand what I am referring to soon with an example. All right, let's see. So, this program is not just intended to spot a bug, it is to introduce several concepts of scope, binding, lifetime of an abstract data type. So, we begin with understanding the namespace used here. So this namespace is not used as a scope here because we are using an existing namespace. So if you want to use namespace as a scope, you would declare namespace and then begin with defining the data inside it so that the scope of the namespace is defined. Now, so this is the class name scope, and this is your main scope. Well, as you know, in the class student, we do have a variable age, and then you have a constructor which initializes the age variable to 12, and there is a function get age which simply prints the age. Then there is a set age which tries to fix the age if there is any incorrection to the data. And there is an interesting function here, get object as reference. This is a function that receives an address of student object and deletes the reference. Let's see what it does. We begin from the main function. At line number 22, we declared an object to the student class. That is, we binded a name to the data type. Obj is the name given to a thing or a class called student. Well, so it initializes the constructor and then age is assigned 12. So when we call obj.getAge, 12 is printed as expected. Next, your get object as reference. So this is an interesting thing what you would want to understand here. So what are we passing here? So you do have a class, right? So you have a class called student and you declared an object obj. So you have binded a name obj to the class student, and as we know, every member variable or every abstract data type will have an address in memory, right? So let us assume this address is 0x1234. What you have done here, you are passing address of obj to the linker time binded function called get object as reference, right? So now, as you have understood, the get object as reference receives a address. This is a pointer variable, right? So in this pointer variable, what are you referring to? You are referring to the object that you have declared. Now when the control goes to the get object as reference, yes, so this is your object ref variable that you have declared. Now this object ref deleted the object ref, that is, whatever is inside this, the contents of object ref has been deleted. So what is the content of object ref? Is the object itself. So this deletes totally. Now, so okay, so you have deleted with this statement. And what happens with obj.setAge? Where is the obj? The obj is dead. This obj has expired, right? So it is being deleted forcefully. So what are you doing? Your binding still exists, but your object itself doesn't exist. All right. So that's the explanation of it. And now the name to object binding to have a lifetime longer than that of the object, right? So your object is dead, but the name binding still exists. Well, why is all this happening? In order to understand the abstract data types and their lifetime and scope, it is better understood with the storage management. What is storage management? So you have different types of allocations that happen in memory for any program that runs. So static allocation, stack allocation, heap allocation. Now any variable that you declare and inside your program will be allocated in one of these three places in your memory. Let's look into static allocation. What is static allocation? Static allocation is compiled time determination. That is, the compiler should know that this variable is going to be stored at the static memory, and all the global variables that are declared are going to be stored in the static memory. Programs machine code and your string literals, like when you say print hello, so that hello is going to be stored in the static allocation. Now what is stack allocation? Stack allocation is the most frequently used one, as you call so many functions in your applications. So there is a stack of all the functions, and each function has a stack frame. So when you take this stack frame, it is typically contains these different types of details. When you are calling a function, so that function has arguments, those arguments are stored in your stack frame, and it has return value, and then local variables that you use inside the function, and along with temporaries and bookkeeping information. So these are all stored inside a stack frame. Next is the heap allocation. Heap allocation is dynamic memory that you create, so which the binding happens, for which the binding happens at the runtime. So in our example, so we said star, that is pointer. For a pointer you allocate with new, so this new actually goes and allocates memory on the heap, and when you use delete, it deletes from the heap. And the next one is garbage collection. So all these three are the memory allocations. And now there is a process to maintain the hygiene of your allocations and deallocation, that is called garbage collection. Well, so now let's look into the interview questions. All the interview questions that are mentioned here are real-time interview questions, which you would face at least one of them if you're attending object-oriented design principles interviews. What is binding time? Now you have understood with the details and explanation, and list of advantages of early binding and late binding. In the spot a bug program, you did notice the advantages with early binding. That is, you cannot accidentally delete them using the delete operator. Now, late binding is something that you do with new, allocate with new operator, and you know the challenges with it. But at the same time, the flexibility it gives you is that you don't need to know how much memory you need before you run the program. That's the unfair advantage you get with late binding. The next question, what determines whether an object is allocated static memory on the stack or on in a heap? Right? In every different languages provide different keywords, like new keyword or operator gives you memory on heap. A plain int abstract data type allocates it inside a function call on the stack. Now, when you declare int or when you use extern keyword in C++, it goes and gets stored on the static memory. And what do you commonly find in a stack frame? We just have seen that. And what is a frame pointer? What is it used for? So each frame, right, is referred to with a pointer. We have used it in order to refer to it. So every program, every function that you have has its corresponding frame pointer. What is dangling reference? You know that the object died, but the object binding still exists. Then it becomes a dangling reference or dangling pointer. And what is garbage collection? Is an automatic process of uh, deletion of unused, not unused, deletion of expired memory. So if you like it, do comment that you like this and what specifically you liked it. If you didn't like it, you hate it, do let me know that, you know, what is that you did not like it, so that I make an improvement, so that I can create new videos. And please send your recommendations if you are looking to watch more similar videos on object oriented design principles. Thank you for watching, and do subscribe to vsdevelopers.io channel.